Hey everybody, this is Larry. This is me going with Q3 of the weekly contest 223. Minimize hammering distance after swap operations. Hit the like button, hit the subscribe button, join me on Discord, ask me about this questions or anything more. For this one, the key thing to note is that if you have these swap maps or swap list, and what happens is that once two numbers are intertwined in the swaps, you can always, every number can get to every other number in that swap map, right? And what I mean by that is that, okay, for example, in example 3, 0, 4, and you have 1, 4. Let's just take those two as an example, 0, 4, and 1, 4. That means that 0 can, the number that's in place 0 can get to 1 because 0, you could swap it to the 4, to the 1, and then so forth, right? So you can kind of, and because you can do this infinite amount of times, basically, if the two numbers that are together, then that means that, well, they're together. So what this means is that for me, I will use union find. And you can actually do a depth first search or something like that if you wanted to convert it in the graph here as well, to kind of get the connected components. And once you have the connected components, because all the numbers that are kind of tied to, or all the indexes that are tied to each other can get to each other, right? And once you do that, you just kind of count, for all those numbers, for example, you just count the number of identical characters that are in the same subcomponent, right? And what I mean by that is, for example, here, 0, 1 are basically in the same group. So then now we just look at 0, 1, there's 1, 1, 1, 1, 2. In the target group, there's 1, 1, 1, 2, right? So then now we know that you could, swap them. You can match the 1s to the 1s, the 2s to the 2s, and so forth. And 3, 4, 4, 5 in the same way. Don't worry, we'll go over the code real quick, which is, okay, now. So first, I have n is equal to a link with the source. This is just declaring the n. And this is my standard union find code. I probably should put in a template somewhere because I think I end up spending like 40 seconds typing this out, which I guess slows me down for contests. I don't really think about it that much, but maybe I should start templating this. But yeah, and then now, and this is union find. I'm not going to go over union find really deeply in this problem because that's the prerequisite for this problem. So if you have struggle with why union find lets you get connected components, definitely practice on the easier problems first. And after that, as we said, if you can swap from A to B or X to Y in this case by my variable names, then you put them in the same group. So that's how I have this union. And then I don't know why I have this scene. I think I was thinking about using a different way. But then after that, I have a map of a map, basically in a language that is in Python. And what I do is that, okay, for each each index on the source array, we go, okay, what is the component number, right? So this is the component number, which is the parent in a union find thing. And for that, we take the source, we take the target, and then we add one to the source, and then we subtract one from the target. So that the idea here is just to get the delta between the two things. And you can maybe have two different counters or something like that, and then just subtract them afterwards. But the way that I do it is that, like, okay, if the source has a 1, this will increment by 1. If a source has a -1, then it would just cancel that back out to 0, right? So then after that, I have a total where I just sum up all the values in these delta arrays, and that's pretty much it. I only count the positive because there's going to be, if I have any negative number, that's just going to be on the target side. So basically, like, that's the number of moves because if one index is contributed in 2 places. So yeah, that's all I have for this problem. Except for that, I always say that and then I forget about complexity. So what is the complexity, right? Well, I do path compression, but that's if you want to upsolve it, let's just say that this union find is effectively O of 1. I know that is log star of n, if you want to call it that, or inverse argument function, if you want to look that up. And that's not quite my implementation, but it's close enough. It usually is not an issue. So that means that for each allowed swap, it will, so if I call this a y, yeah, I don't, okay, just want to make sure about the constraints. So this n is not equal to this, let's just call m is where m is the number of allowed swaps. So this is going to take O of m times for that reason, or n log star of m or something like that. But yeah, this is going to be O of m times because each union operation takes roughly O of 1. These are just all O of 1 operations. So this is going to be O linear times O of n. And again, this is oops, how did I do? This is also going to be O of n. So this entire algorithm turns out to be O of n, because, or O of n plus m, if you want to call it that, where m is the number of allowed swaps. And the reason why is that this is O of 1-ish, again, union find operation. But this is just O of 1 operations, right? And here, you may say, okay, the two follows. Why is this O of n? Well, the reason why this is O of n is because of the union find, each index can only be in one place under one parent. So that means that they only contribute to delta in one place. So that means that if you sum up all the number of counts in delta, that's going to be O of n, if that makes sense. And just to kind of give a little bit of illustration, because I think some people struggle with this kind of explanation, is that, okay, for example, let's say the parents in a union find kind of way is 1 1 1, 2 2 2, 4 5 6, right? So in this case, we can skip the 3 and the whatever, so it never runs out. But for each number that's in here, we only count it once because it can only be in delta sub x once, right? So that's why this is O of n. You amortize it based on, for each index it can only be in one place, and because each index can only be in one place, this can be only added at most once, so that's going to be O of n. That's all I have for this problem. Let me know what you think. You can watch me solve it live during the contest next, and remember to hit that like button. I will see you later. Okay. this. Hey everybody, yeah, thanks for watching. Let me know what you think about this problem and other problems on this contest. And I mean, it's been a while since I finished the top 100, so I don't know. I will talk to you later. Bye bye. Oops, one button.